This is Honors Precalculus, section 1.9, inverse functions. So in this section, we're going to introduce the idea of inverse functions. We're not going to go very deep into this, but we're going to work on being able to verify whether two functions are inverses of each other. And we are also going to be able to find the inverse of a function, whether it be algebraically or graphically. So if you start by just thinking about some of the things we've done so far, we've talked about functions like y equals x plus 4, which is an algebraic representation of a function, but we've also looked at numerical representations in which we have some ordered pairs like -2, 2, -1, 3, 0, 4, so on and so forth. And when we plot these ordered pairs, we can get an idea of what this function looks like graphically. And so we've worked with all the different types of representations of functions. Now we're going to focus on what's called inverse functions, and we're going to see what that looks like for each one of those. And so for any function, I can plug in values, choose x values, and get a corresponding output to find some points. So like here, I would have the points 0, 4, 1, 5, 2, 6. All of those would be part of the graph of the function f of x is equal to x plus 4. And so when I start thinking about taking the inverse of this function, all of our points are kind of going to flip. So for example, the point 0, 4 from our original function, when you take the inverse of that function, you're going to get the point 4, 0. Likewise, 1, 5 is going to become 5, 1. 2, 6, 6, 2, and so on and so forth. So you can kind of see the effect of taking the inverse of our original function on the graph of our second function. Everything has kind of shifted and changed positions because of this inverse. And really everything is just the opposite of the original function. Same thing when we look at the algebraic representation. In the original, we had x plus 4. Now for our inverse, we're going to have x minus 4. So as you can see, the inverse is just essentially the opposite. And the notation you're going to see a lot looks like this. And that just means the inverse of f. Kind of looks like it has an exponent of -1, but that is used to denote the inverse of a function. And so before we look at finding inverse of functions, let's start by just verifying or checking to see if two functions are inverses of each other. And the way we're going to do this is by using the skills we learned last time and finding the composition of these two functions. So after we compose the two functions, if for both compositions we get the identity x, or our composition is just equal to x for both of them, then we would say that f and g are in fact inverses of each other. And so on the contrary, if either of our two compositions do not equal x, then we would assume that they're not inverses of each other. So let's look at an example where we're going to apply composition to see if two functions are inverses of each other. So we've been looking at the function f of x is x plus 4, and let's check to see, let's verify that it is an inverse with x minus 4. And so again, to check this, I need to find both of the compositions between f and g. So first I'm going to find f composed with g of x. And so I'm going to take all of g and plug it in, use that as my input for function f. So f of x minus 4, which is g, is going to be x minus 4 plus 4. And here, when we simplify this out, you would see that your -4 and your +4 are just going to cancel out. So you do, in fact, end up with just x. So that takes care of one of the compositions. Now we also have to check g composed with f of x. And so I'm going to take f and now plug it into g. And so I will have g of x plus 4, which is just going to be x plus 4 minus 4 from our g function, which is also just going to simplify to x because our +4 and our -4 will cancel. And now we've verified that both of these compositions do result in just x, and so we can conclude that yes, these are inverses of each other. So for this problem, we're given f of x is 2x minus 3, and we're told that its inverse is 1/2 of the quantity x plus 3. So once again, let's use composition to verify that these two are in fact inverses of each other. So first, I'm going to find f composed with inverse of f. So I'm going to take all of inverse of x and substitute that into the x value from our function f. And so when we distribute this through, our 2 is basically going to cancel with the 1/2. So we're going to be left with x plus 3 minus 3, which then simplifies to just x. And so now if I check the other composition, I'm going to take inverse of f composed with f. So I'm going to plug in f, 2x minus 3, into your inverse function. And so we will have 1/2 times the quantity of 2x minus 3, and then plus 3, which when we simplify inside of parentheses first, we're going to have just 2x, because our 3 and negative 3 will cancel, and 1/2 times 2x is just x. And so now that we've shown that both of these simplify to x, we can conclude that they are in fact inverse functions. So there's a very large wide variety of things we can do with inverse functions, but I only want to go very briefly into them for now. And so the last thing we're going to look at is just given an equation, how do you find its inverse function? And we're going to assume that the functions we are given for now are all going to have inverses. And so if we're given an equation like f of x is 3x plus 1, and we want to figure out what is its inverse, there's a process that we can follow that's going to help us find it every time. And so the first step says just replace f of x with y. So normally our functions are written in function notation, and that's the preferred way to work with them. But when you're working with inverses, it's just a little bit easier to switch it back to y. So now step 2 says swap your x and your y values. So if you think back to what we were doing previously with ordered pairs and their inverses, where we just basically flipped or switched the position of those two, now with our equation, we're just going to change the position of x and y. And so here we're going to end up with x is equal to 3y plus 1 after that second step. And so in step 3, we're going to go ahead and solve this equation to get the y by itself. So here our first step would just be to subtract 1 to the other side. And then I would want to divide everything by 3 to get the y by itself. And so we would end up with y is equal to x minus 1 divided by 3. But now that you've solved for y, the last thing we want to do is go back to our function notation. So we're actually going to replace the y with inverse of x. So our resulting inverse is the inverse function of x is equal to x minus 1 divided by 3. Now as an extra step, if you're ever not sure if you did the process correctly, you can go ahead and compose your two functions. Do what we've been doing to verify that you found the correct inverse of the function. So let's finish off with one more quick example. Here I have f of x is 5 minus 3x, all divided by 2, and I want to try to find the inverse of this. So again, our first step is just to replace f of x with a y. So we're going to have 5 minus 3x, all divided by 2. Then we're going to swap the position of x and y. So we're going to have x is equal to 5 minus 3y, all divided by 2. And step 3 says we got to work to get the y by itself. We got to solve for y. And so the first thing, since I see this y is in the numerator of this fraction, I got to multiply both sides by 2. So this 2 will cancel with the 2 in the bottom, and we'll be left with 2x is equal to 5 minus 3y. And here, again, I'm just trying to get the y by itself, so the next thing I have to do is subtract this 5 over to the other side. And so I'm going to have 2x minus 5 is equal to negative 3y. And so last step to isolating it, I just have to divide both sides by negative 3. And I'm going to flip our equation around just so we have our variable y on the left side. But we're going to have y is equal to 2x minus 5, all divided by negative 3. And so then step 4 says just take that y equals and replace it with our inverse function notation. So our final result will be the inverse of f is equal to 2x minus 5 all over negative 3. And again, at this point, you can go ahead and take the compositions between f and inverse of f to make sure that we did find the correct inverse.